Welcome to the Slop Farm. Enjoy the video.
You begin by securing high-quality recordings and the right software. Record or source 10-20 minutes of clean mono WAV at 1624 kHz and create precise transcripts so the model learns pronunciation. Once done, set up a Python virtualenv, install PyTorch optimized for your CUDA version, and add a vocoder such as hi-fi-gan. Make sure file naming and folders are consistent so training scripts can find audio and text pairs. This prevents errors later and keeps the pipeline reproducible. You now convert raw audio into model-ready features. First, trim silence and normalize loudness to a stable target, then resample to your chosen rate. Next, extract MEL spectrograms and create alignments with a forced aligner so the model maps text to sound. Begin training with conservative batch sizes and a reliable scheduler. Monitor validation loss and sample outputs frequently. If you see overfitting, reduce learning rate or add augmentation. Save checkpoints regularly so you can resume or roll back to a known good state. You finish by fine-tuning the trained base on the target voice. Lower the learning rate and run a few thousand steps while generating samples each epoch to evaluate naturalness and speaker similarity. Then pass MEL spectrograms through your vocoder to create audio and run both subjective listening checks and objective metrics. Export the model, tokenizer, and an inference script for deployment. If audio is tinny or distorted, check sample rate mismatches and vocoder settings first. Mismatched rates are the most common cause of poor output.
Thanks for watching. Consider subscribing if we helped you today.